Okay, students, this is one more example of how to solve an oblique non-right triangle. This is number 37 in your textbook, so if you want to follow along, I'll walk you through. Okay, so the first thing I'm going to do, just like I did when I was working through 31, if you watch that video, is I'm going to have to decide what I am going to use. And I'm not even going to worry about the fact that I need to look for multiple things in this triangle. I'm going to start with, I'm given a side, an angle, and a side. So side, angle, side. And hopefully from the example that we did, you learned that law of sines, although that's usually my first preference, is not going to work. So I'm going to have to use law of cosines. So I'm going to note that this is a side angle side case, which tells me law of cosines. So I'm going to go ahead and label my triangle. Usually I like to use A, B, and C. This one's already labeled triangle PQR, so I'm just going to go with it. If you want to relabel it A, B, C, if that helps you, go ahead. Otherwise, I'm going to use lowercase letter P, lowercase letter R, and lowercase letter Q for my opposing sides for my angles. And then I'm going to use kind of a modified, again, I don't want to mess anybody up here, but sort of a modified formula from my law of sines formula. And I'm noting that this is my angle that I know. That's the only angle that I know. So if you take your law of cosines formula, instead of using a squared, b squared, or c squared, I'm going to use q squared equal to, then I'm going to have my other two, r squared plus, p squared, minus 2 times r times p times cosine of q. So all I have there is a modified version of my law of cosines. And I'm going to go ahead and plug stuff in. So I don't know q, that's going to be what I'm looking for. R squared is 15 squared plus p is 9. So I've got 9 squared minus 2 times 15 times 9 times cosine of 70 degrees. Grab your calculator. You're going to need to do some calculations here. 15 squared plus 9 squared. You might want to pause this video, do the calculations, and catch up with me. I'm getting 306 when I do 2 times 15 times 9. I'm going to do 2 times 15 times 9 right there. That's going to give me 270 times cosine of 70 degrees. Either type that all in your calculator or do 270 times cosine 70 and then subtract from 306. I'm going to go ahead and type it all in the calculator. And I'm going to get 213.6546. I'm going to leave 4 decimal places. So I now know q squared is equal to about 213 with some decimals. And I need to solve for q, so I'm going to take the square root of both sides. Q, not squared. Q is approximately equal to 14.6. So in terms of what I was trying to solve for in my triangle, I should note that that was PR is about 14.6. So one thing accomplished, I've got that PR is 14.6. I now know all 3 sides of my triangle. So I have 2 remaining things to find, and that would be angle, that would be angle R, and that would be angle P up there. So I now have a choice. I could use law of cosines again with my 3 sides, but use R or P as my unknown angles, and that would work just fine. Or I could go ahead and use law of sines to solve for an angle. So I'm going to go ahead and use law of sines to find an angle. And I'll kind of note that this is step 2. So using my law of sines formula, I'm not going to write it out with letters. I'm going to go ahead and plug in. I know that I'm going to use this combination of the side q and the angle q because I need one pair of opposing pieces of opposing pieces of information. So I'm going to use sine 70 over 14.6 is equal to sine of p over 15. Oops, sine of p over 9 is my opposite side. Let's fix that. And it doesn't look like it'll let me erase. Oh, come on. Sine of p over 9. Okay, we're just going to scribble that out. Is equal to sine of r. That's going to be over the 15. R, opposite side, 15. So, using that, I need to solve for both p and r. P is an unknown, r is an unknown. So, I can go ahead and cross multiply here. I'm going to use the first bit here. And if we want to kind of highlight that, I'm going to use the first bit and solve for p. You could do it the other way, and you could solve for r. It makes no difference. When I cross multiply, I am going to get sine of 70 times 9 is equal to 14.6 times sine of p divided by 14.6. And this should look a little bit different for you. When we've used law of sines in the past, we've been solving for a side. I'm actually solving for the angle this time. So I'm going to throw that all in the calculator, and I get a decimal of 0.5793. I'm going to leave 4 decimal places. 5793 is equal to sine of p. And recall, if you're solving for an angle in the calculator, you're going to be doing the inverse to cancel that out. So, whoops. So I've got sine inverse of my decimal 0.5793. So that cancels, and I end up with p is equal to approximately angle p is equal to approximately 35.4. They said round to nearest degree, so 35 degrees for my angle p up here. You've got one more thing to solve for, and that would be angle r. Don't make more work for yourself than you have to. Now that you know this is 35 degrees, you know 2 angles of your triangle, and my third and final step is to solve for the third angle. And no, you're not going to do law of sines or law of cosines. You are going to use the fact that the 3 angles of a triangle add up to 180 degrees. So, I'm now doing 35 plus 70, getting a good old 105, 180 minus 105 is giving me the angle R is equal to 75 degrees. Done deal. I've got my 3 pieces of information, angle R, PR, and angle P. So that's an example, a second example of how to solve an oblique non-right triangle.